is two different ways of solving this question 19, or a few different ways of solving this question 19, okay? I think it's an important question because it gives you a bit of a training or a bit of a summary on summation notation, different properties, how well you can handle those summation notation in a setting where it's not very familiar, okay? So let's start with the first one. The first one is show that y bar is equal to nb times y bar b plus nt times y bar t over n. What's the easiest way to go about it? Well, it's to realize that y bar is simply the sum of yi divided by n. That's by definition of a y bar. The next thing to realize is that yi, the sum of yi, can be divided into wages for white people and wages for black people, right? So if I were to do that, I could do a sum from 1 to nt of the yi. This is the sum of the white people. This is the sum of the black people. Okay. But here's the other thing to realize. How could a sum be written differently? Well, sum of yi's, sum of wi's, is simply equal to n times w bar, right? If you divide both sides by n, that's what you get. So the sum of the white wages can also be written as the average of white wages times the number of white people. And the sum of the black wages can be written as the number of black people times the average wage of those black people. Okay? So the moment you saw that, then you'd exactly come up to this conclusion here. Okay? Another way that you could have seen that is imagine that you have a sample. Okay? You split it into two parts, black and white. You have some average for the black and you have some average for the white. What is the average of the whole sample? Is the proportion of black times the average of black plus the proportion of white times the average of white. And effectively, that's what this is, right? Another way that you could have rewritten this is you could have rewritten this as NB divided by N times WB bar plus NT divided by T times WT bar. Okay, so you could have looked at those proportions of things. Okay, let's look at the second one, B bar. Well, let's go to the definition. B bar is simply the sum of BI's divided by N. But what are the values that B can take? Dominic, what are the values that B can take? 1 or 0. So I could divide that sample into sums of zeros and sums of ones. How many zeros will I have? As many as I have white people. How many ones will I have? As many as I have black people. So then I'll have 0 times NT, 1 times NB divided by N. What's the interpretation of this NB divided by N in English? How would you describe beta bar? The proportion of black people. Okay? The proportion of black people. Okay? Now, the third question has generally been quite challenging. Okay? And over the years, I've seen that question C tends to pose a challenge to students. What I'm going to try and do is I'm going to show you two answers. Okay? One is from Charlene on the first group today, and the other one is from Ting Ting. They take two very different approaches and they get to the same answer. And I want to show you those two different approaches. I want to break down those different approaches, and I want to show you that those two approaches are not the only ones. Okay? So don't feel like you need to have some, some superhuman power to do this kind of questions. Okay? We'll try and discuss what each of your colleagues have done. So let's look at Charlene's question, Charlene's answer. Okay? Here's how Charlene is approaching this. Let's take this, one at a time. Margaret, when you go from this step here to this step here, what properties or what things has she used?
She's just FOILed it out, like multiplied.
Yeah, she's just simply done a squared minus b. A minus b all squared is simply equal to a squared minus 2ab plus b squared. That's the only thing that she's done. Joanne, when I've moved from here to here, what has she done? What is things that she has used in that process? Dennis?
Well, she like the number because there's a sum of each
Yeah.
separated it into individual.
Okay, so the first thing that she used the fact that the summation notation is a linear operator. Linear operator. So if you have something like sum of A plus B plus C, you can divide it into sum of A plus sum of B plus sum of C. That's the first thing that she's doing. Okay? Dylan, what else is she doing there? That's not the only thing that she's doing there, right? Definitely that's the thing that she's doing when she moves to this term here, right? She has just left that term as is, as a summation notation. But she has done further simplifications on the second term and the third term.
She split that second term. She put the sum in the middle of the.
What allowed that to do that?
Because the mean is on the outside.
Why are the means on the outside? Why can we put the 2, the minus 2 and the beta on the outside? Jay? What has she done here? Kyra? Because the mean is a constant, doesn't have an I, doesn't change, I can pull things out of the summation notations. So another thing that she has used here is constants can be pulled out of summation notations. Okay? What's the final thing that she has used for this final term? In this final term, I don't see a summation notation at all. So what's going on there?
Is it because it's just the mean? So it's just a constant?
Because the thing on the inside the summation notation is just a constant, I can just write it as n times that constant. Okay? So has she explained this step from here to here? No, she's just written that. Should you explain that in an exam? No, because it should be obvious to the examiners, right? The examiner will take those things for granted. When were these properties introduced? In which lecture were these properties introduced? In the first one, right? So you really need to make sure that everything that was introduced in that first lecture, you fully understand that, because we're using it all the time and we're taking it for granted that you understand it, okay? Mara, going from this step here to this step here, what has she done?
So given that BY is a dummy variable, BI squared is the same as BI, so we should just simplify that.
Yeah.
And then she used the average formula to come up with the second derivative with n. Like
Yeah, so she used the average formula here to come up with this. Yeah, very good. And that's what she did here. Okay. Rehan, what did she do in the next step?
She just simplified it out. I feel like they should took the minus 2 and BI and then plus and then ended up with minus B.
Yeah.
In the second part, and the first part was just what we said earlier, that BI is a dummy variable, and so it's going to simplify out to NB.
Yeah, because it's just going to be NB1s and NT0s. So the sum of B is just going to be NB. Okay. And then here she substitutes from part B what B bar is, and then she does some manipulations until she gets to the final answer. Okay. Now, is anyone feeling like, I would have never thought about that step, right? Or maybe I wouldn't have thought about that step. And you might get yourself stuck, or you might get yourself into a frame of mind that, well, I can't really do this, or I wouldn't have done it this way. The good news is that it's okay. You didn't have to do it that way. What is the big picture that you should have all seen? The big picture that you should have all seen is that, did you know where to start from? Of course, you all knew where to start from, right? Did you know where you should have ended? Of course, it was part of the question. You knew you should have ended here, okay? What is the big picture? The big picture is get rid of the b's, right? You have an expression for beta bar, and you know that the beta i's are either 0 or 1s. So the big picture was get rid of the b. and then simplify up until you get to that final answer. Okay? Yeah, Dylan.
I don't understand. You know, in the first step, why is it going from b squared to just bi?
You mean in this bit here, right?
Yeah.
Is that right? Because she thinks of the context of the question. Bi can only take two values, either 0 or 1, because it's a dummy variable. What is 0 squared? 0. What is 1 squared? 1. So beta I squared is the same thing as beta I.
Yeah. Okay.
That's what she's using. In general, that's not going to hold true, but it's going to hold true for dummy variables. Okay? It's going to hold true for dummy variables. Good. Everybody with me? Yeah? Now, let's look at another way. So Ting on the other class provided some different way that almost might look a little bit different. Or might look very different. Right? So let's look at her way. Okay? Edison, what is she doing from this step here to this step here? Amari?
She's just like using the result from question B, which was that the average of black people is basically the proportion of.
Yeah, look at the approach. It looks different because the other student didn't do this at the beginning, but ultimately the goal is I'm here. I want to get here. This final answer doesn't have any beta bar, it doesn't have any beta I, so I need to get rid of them. Okay? So instead of opening this up, she gets rid of this. That's the first thing she does. Okay? Joanna, when I go from here to here, what do I get? What is she doing as she going from this step here to this step here? Mara?
She takes the black and white separately, and then she uses the properties of 1 and 0.
Remember, the big picture was, I want to get rid of this bi as well. And I know that this bi sometimes is 1 and sometimes is 0. So in order for me to get there, I would need to split this into two parts. The black and the white. And then she knows that beta I for black is equal to exactly 1. And beta I for the white is equal to 0. So it disappears. Okay. Now everything she's fully gotten rid of. She has fully gotten rid of the betas. Very different approach from the first approach. The first approach tried to simplify it and then substitute the betas. The second approach tried to get rid of the betas as quickly as possible. Step 1 got rid of the beta bar. Step 2 got rid of the beta i's. Right? Now it's a matter of just simplifying and seeing if this expression that she got here, she can end up with the final answer. Okay? Well, the numerator is promising, right? The numerator is the same. So she can only deal with the denominator bit. Okay? Everything here is a constant, so I can just multiply nb times whatever it's inside, nt times whatever it's on the inside. She makes n over n, so common denominator for the 1. Okay? And then she makes everything has a common denominator, so it's n square, and joins this together, nb times nt square. Right? And then if you ever got stuck here and you say like, well, I really don't know what to do here, right? You could have said, I really don't know what to do here. Well, you realize that the denominator is n and you have n squared here. So you need to simplify by n, right? You need to divide by n both the numerator and the denominator, okay? So that's what she does. If she figures out a way to get n at the top, okay? nt plus bt is n, and thinks this will simplify with this, and we'll get to that final answer that she wanted. No, they're very different approaches. You could have come up with a third approach of your own. It didn't matter. As long as you knew the properties of summation notation, and you didn't make any mistakes on doing different steps, all you had to do is simplify and go to this final answer here. Okay? Now, I'm not saying that you'll be able to do this in a minute or two. It will take a bit of practice, right? if the summation operator properties are not second nature, you'll be more likely to make mistakes. So what you want to do is you want to make sure that you practice on those summation operator until all properties are, pretty much second nature, so you don't make mistakes. Because had you make a mistake anywhere in here, then it was really hopeless, right? Then it was really hopeless. Okay, so I will stop this here.